It's a great privilege that I still, I mean, through technology, we can still connect and see each other after, like, say, 10 years. So, yeah, so hey guys, I'll just give a brief intro. So Mayank sir, I might not be knowing that what is the background of everyone with respect to AI. I've kept
Chanu,
the
these are,
briefest, yeah.
yeah, students from a mixed background, first year, not first year, second year, third year. The students are there.
Okay.
So
Mhm.
we wish that you start from very basics and land up with what industry wish from them.
Okay, okay. Yeah, so let me share, like, hope my screen is visible to everyone.
Yeah, visible, Chanu, visible.
Okay, thank you, sir. So, okay, so brief info about myself, as Mansur already gave some information about what I do and what I've been doing. So, yeah, so yeah, I've been leading AI research with Cognitive Scale. Cognitive Scale is a Texas-based startup, and we work in trusted AI as well as a lot of other services. So yeah, so I'm leading the AI research team in India with Cognitive Scale. Before this, I have been part of like multiple industries, as well as have been part of academia as well. Like I have interacted with Triple IT for quite a brief time because I have been staying in Hyderabad for quite long. So I got an opportunity to go there, interact with the professors. So we have worked together on solutions with Triple IT Hyderabad professors as well. Yeah, so I've worked in, I started my career with Infosys being one of the companies which came to our college at that time, I remember distinctly, and among many other companies that came. So I joined Infosys, served there for like 3 years, and there I was working as a big data and then sort of like a ML guy. And after that, I joined a consultancy firm, Ernst& Young, for like I stayed there for 5 years. So there I was like sort of became a manager with data science. So I was doing like a lot of data science over there. And then I joined this startup company, Cognitive Scale. And here I've been more into like research oriented roles. Okay, so I have worked in like different areas like distributed computing, software engineering, machine learning, reinforcement learning, which is part of like machine learning. And then also I've worked across like geographies. Uh, so I've been to US, Europe, and UK. And then, yeah, so currently pursuing my research from Triple IT in robotics. And yeah, so moving on. So yeah, so this is the agenda. I was thinking that I will keep uh, the material very basic and then try to make sure that you all get some kind of interest because this field has grown a lot. Like in past 10 years, this has now today there are a lot of people who are doing research in this field. There are a lot of PhD students who are coming out of colleges, right? So this field is like in a boom as of now, and I think the expectation is like coming few years. So for you guys who are just students as of now, if you get into this field, sort of like as do some basic courses in this field, try to do a master's in this field, and try to pursue this field. This will be very good for you, like going forward, because we know that the number of students are increasing in this field by leaps and bounds. Number of researchers are increasing in this field. But yeah, miss. So this is the right time because the landscape from what we see in industry is changing a lot. The landscape, which was more about software engineering focused, now is slowly becoming more of like AI plus software engineer. So now there is a lot of means we do a lot of software engineering as well, like Kubernetes, and you have like entire tech stack for SRE, for DevOps, for quality assurance, and all those things are there. But I think like the pivot for coming to a solution is now coming more on. the AI side. So yeah, so this is what I thought like I'll cover up. These are all very basics. So I have a lot of slides to cover. I think we have couple of hours, the invite I saw. So we'll have sufficient time. And I think like the overall idea is just to introduce the field to you guys and to make sure that you start like looking into it, reading up, and doing some kind of work in this field. Okay, so yeah, so these are the topics I would be covering. Okay, so the idea is mainly to kickstart your interest in this field. So we'll be sharing some knowledge so that you can get started on your own. And yeah, this is just going to be a gentle introduction to machine learning because yeah, that's what I came to know about the audience. So yeah, this will help you guys to get a holistic picture, I suppose, of machine learning, and then obviously as you start working on your own or join higher studies, then it would be very useful, or join industry obviously. So yeah, and I have few cartoons as well. So hopefully those of you who have been asked by Mayank sir just to join, so you can enjoy that. And yeah, so there is no mathematical formula. I don't think like I've kept anything in this slides. So yeah, so let's get started. Yeah, so what are the challenges we face in today's scenarios? So one is like the world is becoming drastically interconnected world. So we are living in a world which is lot of data, lot of inputs. We are not living in an isolated world. We are interacting with clients who are across geographies. We are solving problems of people who could be sitting in some other geographical location. All this is because now today, obviously, internet was the main reason, but slowly the things have been that the the geographical the limits, the boundaries of a countries are like sort of like with technology, we can interact. We have friends across social networks and all those things. So yeah, so that is one thing. And when the world has become a lot more interconnected, so with it comes a lot more diverse kind of problems that could be there, which we would like to solve. Yeah, and again, like the organizations have become very complex. So we do not have like even a simple payroll system is not that simple in most of the organizations, or the HR systems in the companies are not that simple. So there is like, for example, if we take HR itself, so HR was earlier that the role was more about okay, so what are the salaries of the employees, how the employees are doing, getting feedback about the employees, and making sure that we get, I mean, the HR team gets recruitment done properly, so managing people. But now the scenario is like everyone wants to understand more about their employees. Who is the employee who is like performing better? How do you measure? So there are a lot of metrics which is available. Your quarterly assessment that is being done, all those information, or your how do you handle a project? All those different kind of inputs are available, and people or HR team. So every structure today is now sort of becoming more and more complicated, and with it, like the problems are like how do we solve all those scenarios, right? So even the most basic things, which because earlier we did not have access to the data, or we did not go to lengths to understand like okay, how do we interconnect all these dots? Now because of the data, because of the access, we can do that. Okay, so and obviously like there is a growth of us also wanting to live in like smarter cities. We have a lot of different facilities that we ourselves want: data privacy, data governance. A lot of these kind of things are there. People want like better access to a lot of quality stuffs, which I think previously, because of, again, these are all things which are coming because the world is sort of like gravitating towards more technology. We are getting interconnected a lot. So yeah, and then obviously there is a lot of compliance and regulation that is coming into picture because of like we keep hearing about the laws being passed to make sure that whatever data Facebook or other social media sites are collecting about the users, they are used properly, like whether it is Twitter or something like that. Again with Google, so all these behemoths which are like e-commerce, there's like we do a lot of Amazon shopping, we do Flipkart and all those things. So there's a lot of data, but again, like the government would like to have some kind of regulations in that field. So, how do you regulate all this diverse fields? This is again like a major challenge. How do you make sure that the data privacy is kept strictly, like whatever data belongs to different users, they are not being misused. So, if the data belongs to one particular group of users, they are not being used without the user's prior permission for the benefit of the company, right? So for political gains or whatever, right? So and I think with the coming years we'll see lot of our data sets, like even the healthcare data set would come into the regime where it would all be online, and obviously people would like their healthcare data, which is which should have like tighter privacy laws and all those things. Okay, and okay, so yep, so with it comes like a lot of different threats to the system also come into picture. Like the threats have also evolved a lot. So there are a lot of chances because of our online presence. There could be a lot of chances where you are being or your data is being compromised, right? So all those problems keep coming, and the overall idea is like, okay, there are a lot of problems, and how do we go ahead and try to solve all those problems, right? So yeah, so this is again along the similar line, just giving some stats that okay, there could be a lot of malware attacks and all those things. So we should be in a position that we can proactively make sure that the system, whatever system we are in, it's protected. It's we are made sure that none of our private data or all those data which we have, because our online presence is increasing, and it's just a matter of years when we'd have like a digital clone of ourselves. So industry, or the way we see that the industry is moving at a very vast pace, especially like the boundaries between technology and your personal life is decreasing. So we are now, most of us are glued to the phone, right? To our, so the screen time, most of us either spend time on the computer screen or on the phones or several digital media, and this is going to increase only. With it, like you have to be very careful, or the systems have to be designed in a way wherein the systems are able to proactively stop a lot of these issues. And yeah, so there means robotics is another field which is growing a lot, and with coming days, it's people have already reached, or some of the companies, you guys might have also seen some of the videos wherein you can see that uh, companies have come up with robots which can do certain jobs. They can run, they can pick stuffs from the ground, they can do some kind of like delivery of, like their drones, and then comparable robotics advances in that field, which has done a lot of like benefit in the term, like there are a lot of uh, and this is going to increase, like we would see that instead of man coming and delivering us, we could have drone deliveries, we could have robots doing a lot of chores for our households in the coming year. Like we don't know the like the time boundaries, but yeah, I mean, it's just like one breakthrough, and few of the breakthroughs that come in, all of a sudden you see that the world changes drastically. So it's just a matter of like couple of breakthroughs, and then some of the hardest problems which were not solved because of whatsoever reason, like AI, for example, like there was a AI winter wherein all these algorithms were there, but people didn't know how to solve them because of the infrastructure issues. Now the infrastructure issue is like sort of like it has gone down. We have TPUs, we have GPUs, and all those infrastructure has become very cheap. So with that, the AI algorithms and the world has changed. So certain breakthroughs wherein a lot of companies are working, especially in AGI and all those fields, would enable like a lot of these things to be more like we can interact with all these things in we can expect to interact with all these things in our coming days. Okay, yeah, so cybersecurity is another area. I think we have briefly touched on this that okay, since our online presence is going to increase manifold times, so this is another field that becomes very important, that the cyber laws, especially our presence and all those things, are strictly guarded. Okay, so this is where like we can try to understand that what is AI, right? So it's more about how do we model the human mental functions using computer programs, right? So it could be like I want to you to create artificial intelligence that is as smart as me. Right? Okay, I should have that by lunchtime because you are a fast worker. Sure. So this is some kind of like yeah. So the idea is that AI is becoming like a day in day out activity that is going to interact with us. That would be it's already doing as of now. Like a lot of fields we may not be using. We are using Ola, Uber, we are using Swiggy, Zomato, and all these things, right? We are using Big Basket. From Indian perspective as well, if we see there are a lot of things which already have all this smart decisioning system. So whatever was earlier being done by people, now all this is being done by artificial intelligence. Okay, so AI is like it comprises of two words, artificial and intelligence. So artificial is something which is not natural, right? So which is created by humans. That's what we say by artificial. And then intelligence means that ability to understand, reason, and plan. So there is like this idea that okay, we can create something which has the ability to make decisions, right? So that is what artificial intelligence is. Yeah, so which can demonstrate, and the biggest example for us is our human beings. We as a human being, we always try to mimic whatever we see around ourselves, right? So planes were designed seeing the aerodynamics of birds and all those things, right? So everything we see around ourselves, we try to create machines out of it. And similarly for the human being, that we are the best decision making system if we can think of ourselves as of now in that way, which is obviously which has a lot of bias and all those things. But yeah, so we are one of the best decision making systems as of now, and we'd like that can we design some algorithms or some kind of a machine which can augment or which can hello, is my voice audible?
Yes, Shanu, it is audible, sir. Shanu, it is audible. Some were having a problem, so I just typed a message
Okay,
that it is all clear.
okay. Should I just turn off? Give me a minute. Okay. Okay. So yeah. So moving on. Um. Yeah. So I wonder whose job I'll take first. You could never do my job, is what I think. Like most of us also think that machines are not going to replace us, but they are as of now. They are sort of like so. This is what the cartoon says that okay, as of now, so this machines are sort of like taking the jobs. Like a lot of mundane jobs that was being done by human beings is being replaced by machines. Okay, so what are the possible applications of AI? Yeah, so it has like these are only some of the limited areas, but believe me, like the areas are really very vast. Natural language processing is in boom like these days. If any one of you who is sort of interested or is being reading about natural language processing. So natural language processing is like you read a text, and for us, it comes, we can understand the text, right? So whenever we read something, we are able to summarize it. We are able to ask questions about it. Or if somebody asks questions about the text that's shown to us, we can give an answer to that. So all those activities which um, we as a human being can do just by seeing or reading a text would fall under natural language processing bucket. And then there is deep learning. Deep learning is like it sort of mimics whatever the human brain is and tries to do an end-to-end learning of just being presented some text or some video or some images and try to come up with answers or solutions to it. So there are different areas. We'll be covering some of these, maybe like at a very high level in next slides. Then there is modeling, how you can simulate something and create models out of it. Machine translation, you might be using Google Translate for this a lot. I have also used a lot because in Hyderabad, the native language is Telugu. So at times I would try to like use this. So yeah, means machine translation is there, social network analysis. Machine learning is like sort of like at a higher level bucket. Then robotics and soft robotics, Internet of Things, image analytics. This is another very critical areas which some of you, if you are interested, would this would be a very good area which is growing a lot. Then graph analytics, audio analytics. So you have Alexa, you have Siri. Those of you who use these audio chatbots, right? So you know that they can hear you and then they can respond you in a way like which is very human-like. Maybe at times that's not that good, but yeah. But the overall idea is that there is a capability to do audio processing. So something similar like that, virtual personal assistant. Now this is being of increasing help to companies, especially like those who run call centers. They like to cut down the cost of like taking a lot of customer calls based on the individuals. So they would like to make it more sort of like automated. Okay, so one such example, now this is slightly old news. So this is with respect to MACD trying to have some kind of AI in their system. So they went ahead and they acquired a company called Dynamic Yield, which is an Israeli company, and they wanted to do like some kind of recommendation for what they should sell. So yeah, so the overall idea was that a fast food selling company like MACD also wanted to have some kind of assistance wherein they can know proactively that okay, at this time of the day what sells best or what should be on the menu. So all those kind of things is like personalization is another very big thing that we all uh, generally when we watch a Netflix movie or Amazon Prime movie or YouTube, we get recommended contents a lot, right? So those kind of things wherein all the companies want to know more about the end user they are serving. So in a way, like they want to get your implicit feedback that how did you like the movie? If you are like, if YouTube shows you a video and you just don't see it and walk away from it, so that is some kind of a signal that goes back to Google saying that okay, the video that you've shown to so and so is not that useful. So all those kind of signals, we are constantly interacting. If we are reading something on some blog on internet, the dwell time is being captured. How much time do we spend on reading an article, right? How many links do we click on that article? All those events are captured, and these events help the companies to better their algorithms, as in like give you more personalized content. So yeah, so MACD is doing something similar. They have already acquired this company, and they are sort of doing some kind of recommendation as to what should be on the menu. Okay, so yeah, so there is definitely an increase in the popularity of AI, right? So we can see that in the courses that are being offered today. So IISc has started offering MTech in artificial intelligence, which like we would not have heard about like when I was doing bachelor's with at that time this was not even known that artificial intelligence. We just had, I remember there was one chapter uh, in our final year which just talked about like what is artificial intelligence and what is the comparison with human neural system, right? So that was just a small chapter, but now we see that courses which are like catering to especially to artificial intelligence, a lot of courses are being offered. If you go to Coursera, Udemy, and all those sites, I know like probably some of you might already be going through them. So a lot of courses are being offered. The amount of videos or the amount of online material which is available, it has grown humongously. So if you guys are interested, then you can, it's just a click away that knowing anything, trying to research on anything, or trying to learn on anything, especially in this AI field, there's a lot of people, a lot of community. This is just a thriving community which is ready to offer you a lot of help, guidance, and that way that this makes learning much more easier. And CBSE has also integrated artificial intelligence in their school curriculum. So now school students would have some sort of like they would be knowing what is artificial intelligence, which is, I think, is a very good step, especially seeing our current education system in India. It's like a very proactive step. Like we are sort of like getting closer to the global education system. We are trying to make sure that our students are up to date. So yeah, I think like this is another very good step. Okay, so let's see, like there are a lot of terms that are tossed around, especially in this field, that what is AI, what is machine learning, what is data science, right? So very similar fields, they have a lot of common boundaries, a lot of common areas. So data science would comprise of some of these machine learning, AI, and deep learning technologies, along with if you put in the maths, the statistics, visualization, the exploratory data analysis, the databases, and all those things. So that is all related to mostly about how do you understand data, how do you see data, how do you visualize data. So all those kind of like statistics, there are a lot of, before even machine learning came into picture, there were statistical methods in which economics or people who used to do stock predictions and all those things, like all those fields used to use a lot of statistics. Deep learning is has seen a lot of boom from past like I would say 10 years or so, like less than 10 years, maybe 6 7 years. So deep learning has become so huge, like and one of the main reason is because of the infrastructure. So deep learning needs a lot of data to start with, and today, so those could be like two things. One is the availability of a lot of training data for these models to get trained on, and second thing is the infrastructure. So both of these are available today. So yeah, so deep learning is a subset of AI or machine learning, wherein you do an end-to-end learning, right? From images or from audio or from text, you come to a conclusion saying that, okay, this image is about what, right? It could be like, or you could also get an answer to like, if you are like one of the problems that in our company we tried to solve was for a housing company, wherein we wanted to come up with a solution saying that how good the houses are. So there was some rating given to different houses. So we had to come up with a solution wherein saying that, okay, this house has this many bedrooms, seeing just the images, right? What is the condition of different appliances in this house? So, and then saying that what is the rating of this house? So this helps this helps the housing company in a way that they can now give different ratings, different prices to different houses. Even they don't even need to have to hire a lot of people who can do manually, who can intervene and say that, okay, you know what, this should be the quality of the house. Or if somebody re-innovates the house and they upload their pictures of the house, based on the pictures they can give. So this cuts down the human effort required to give an assessment, and for the housing company and the end customer it's pretty useful, because they can now go ahead and say that, okay, you know what, like this house, it's highly rated, I can uh, and this is the price. This is a win-win for both customer as well as the company. The company can, based on the predictions that it gets from these images, can say that, okay, this is a highly rated house, and based on the suburbs or the area where this house is, I can charge this much. So this should be the price of the house. Yeah, so deep learning has is like sort of booming a lot. There's a lot of research being done in deep learning, and a lot of papers are being published in deep learning as well, whether it is natural language processing, image processing, speech, and yeah, so these are like core areas. But apart from this, also like improving algorithms with respect to each of these fields. There's a lot of data that is available, especially with the big companies like Google, Facebook, companies like that. So yeah, so deep learning has grown a lot. Machine learning is comprises of slightly, like, not the end-to-end uh, automation of, like, you just feed in the image and you get the rating. You just feed in the text, you get some kind of sentiment or polarity of the text. You feed in the text, you get the what are the important concepts in the text, right? So you feed in a text and you get a translation of the text. So machine learning is more like, there is a concept called feature engineering with respect to whenever you have this kind of text data or the image data, wherein earlier, before the advent of deep learning, people used to do, and they used to get very high payment, especially people who were doing image processing and research in that field. They were paid handsomely to design filters. So filter was something which could, like, overlay on top of these images and identify that, okay, these are the basic abstracts that is available, and they could pick out those abstracts from these images. So yeah, so machine learning doesn't do that end-to-end processing of it. You have to have a human intervention, wherein the human being is going to design the feature, called feature engineering part or the pre-processing part. And then you have a standard set of, like, machine learning algorithms, which could be decision trees, which could be like support vector machines. And there are a lot of, like, machine learning algorithms, which sort of like, which you can assume these algorithms as functions which take whatever features you have designed for them, and then give you maybe the class of the different classes of the image, like what should be the rating of the image if it is 1 to 5. Now it's a multi-class classification problem. So those kind of things, machine learning. And AI is like at a much broader level, which is like, which has all these different kind of algorithms, and it's like a, you say that it's a bigger group which comprises of all this different areas. Okay, so what is machine learning? Machine learning, yeah, so it's basically that you do not have to program. Like most of us, we are software engineers and we do a lot of programming, right? So we can write a program to achieve a specific kind of a job in any given programming language, like whether it is Python, Java, C++, or so on and so forth, right? So without even there are a lot of problems wherein you cannot program it explicitly. um, so how do you solve those problems? Basically, if you have an image, how do you identify that this image belongs to a cat or a dog? These kind of there's no easy way to, like, literally write a program for that. So machine learning solves based on data. Like you just give it the data and it indirectly writes the program for you. So it's still writing a program for you or code for you, or sort of like if we can think in terms of rules, then it is writing so different kind of rules. But okay, if I observe this particular feature, then this belongs to this. So yeah, so this is something like sort of like funny thing that we can see that okay, internet based on my internet, your internet history, you might be dumb enough to enjoy extreme sports. So click here to buy a ticket to base jump from the International Space Station. And the guy says that okay, is it trying to kill me? And it's sort of like okay, this is what we call machine learning, right? So based on your data, it tries to give a prediction of like what are your likes, what would you like to do, and all those kind of things. Okay, so moving on, like there are like different kind of machine learning. This is not covering the different tenets of machine learning as such, but at a high level, like what happens. So we can have unsupervised learning, we can have supervised learning, and supervised learning has some kind of feedback which is available as part of labels. So it could be like if we are doing sentiment analysis, so it could be like okay, this text or this news is negative. Overall, somebody can come and say that okay, or somebody labels this news article saying that this is negative. Unsupervised is more about you do not have labels, so you do not have the feedback coming in from an instructor or somebody who's providing you or a teacher. You just have a bunch of data. Like just assume that you have a lot of pictures, like Google Photos, right? So we upload a lot of photos. How does it know that these are photos of particular person A versus B versus how does like or these are the photos of say furniture or table chair and all those kinds. So it does it without even most of the time it doesn't even know that okay, um, these photos have some kind of a label. So it does more on like similarity. We can just assume that okay, what could be the how similar this image is with the next image. So some kind of a notion of similarity is there, based on which it tries to bucket these different groups. That is like the unsupervised piece of it. But most of them would do a feature extraction piece, which is kind of like take important features out of all this unstructured data or the initial data that we get. And then there are a bunch of algorithms, which are the machine learning algorithms, and then they can come up with a solution. So in our supervised case, it could be a predictive model, which is going to give you the output that, okay, this image is of a cat, or this text is negative or positive or whatever. Or it could also create groups of like similar things together, like photos, they could be like similar photos and so on and so forth. Okay, so a brief history, like how did this entire thing, but we have talked a lot on this, just at a high level, that initially it was all manual, and in every field, that's how it progresses. A lot of manual things come in first, and then you have sort of like an automated way and more intelligent systems trying to replace it. So it was initially people were guided more by uh, experience. There was a lot of people, especially in domain-centric industries, who were kept there because of their they had a lot of experience in this field, and they could and companies could rely on their gut feeling, saying that okay, you know what, this strategy is not going to work. So initially, it was like that, and with the advent of a lot of online data being available, the process started shifting. That okay, whatever can we also do some kind of analysis of it on based of whatever data we have and come up with solutions. So this was more about like a shift, a gradual shift, and then obviously statistics started playing a major role, majorly in terms of like if you are doing a time series prediction and all those things. So there is a lot of statistics involved, which still does very good job. Most of the methods for time series analysis is like the standard statistical methods that's being used. And so statistics is still like a major part of machine learning, whether it is probability theory, whether it is something like a Bayes algorithm and all those things, right? And then it's more about like automating and getting to a position wherein we minimize the human input, or sort of like we have automated data points and we want these algorithms. Now this has helped in multiple ways. One is like you can scale, right? So with a human in the loop, right? Or if there is a huge dependency on a human being, then scalability becomes, transfer of knowledge becomes very difficult. And with machines, you can easily do some kind of like transfer learning. You can make sure that it can be scaled. It just depends on how much hardware do you have. Okay, so why is machine learning sort of like different? So yeah, so we can see like couple of babies. For us, it's like natural, but this is basically an image, and to a system, it's just bits, right? So just some sort of numbers which are there, and this is what the machine learning algorithm would see. For us, this happens like uh, in a snap of second. We can see that, okay, and we can tell like, okay, there are different segments in this picture. We can tell where the babies are and all those things. But the same thing for a machine to do, it's like a totally different thing. So our intuitive way of doing certain things, especially when we write programs, we think from our intuition, like this is how we should progress, right? We do not think in the low level word of like, okay, this is ones and zeros. We do not think in that way. But especially with these machine learning algorithms, everything is one and zero. They do not see this image, they see ones and zeros. And from that, they try to find out that, okay, you know what, like the photo contains two babies. And especially if you see Pinterest, I don't know, like if you guys have used it, like, or there are a lot of like photo or picture related apps, yeah, Instagram and all those things, right? So there are a lot of those apps which can tell you a lot of like they can, if you search, then you can get very similar images and something like that. Okay. Yeah. So over here also you can see that I think the text is cut over here. But yeah. So what is true in this, like in this image? It's very difficult for even a human to identify what are twos, right? So these all like look to be two, like these all look to, and these are mostly three or four or something like that. This could be seven, right? So these can look like two, right? So it's difficult or it's different. Like I would not say difficult, but it's slightly different problem because there are different ways of representing the same object. So a two can be written in so many different ways. Similarly, a photograph of an object can be taken from so many different angles. To zero in and tell that, okay, this is these all these photographs which have been taken from different images, or all these different writing styles all belong to, or especially in speech, just think about like people from different regions in across geographies have different uh, intonations, their style of speaking is different. um, but yeah, so combining all those things is very difficult, very different, like. Okay, and over here also we can see that, okay, this is an image of an apple. This is something similar which is looking like which is a plum, but it looks like an apple. And this is the Apple image from like the Apple Corporation. Okay, so yeah, so we briefly talked about this, that what is this deep learning principle that is being applied over here, or machine learning principle. You see an image, you create some kind of filters. Using those filters, you have the initial features coming in, or for a deep learning system, you just feed in this image, and then there are a bunch of layers which sort of like try to find that, okay, what are the different weights that should be assigned to all these things, and then finally predict whether it's a cat or a dog or whatever it is, right? And then there is another section which is called Explainable AI, and this is in Boom. Our company also does a lot of research in Explainable AI, we or say trusted AI. wherein like most of the machine learning systems today are black box systems. So we know that there are arbitrary weights assigned to all this. Like there could be billions of nodes, and all those nodes have weights. Especially with today's growth of the model size, right? So a lot of models have become like 170 billion parameters and all those things. So it's very difficult just from the black box model or seeing the weights for us to understand that why the model is behaving in a particular way, especially at times like for critical operations, like for example surgery, or for financial healthcare sectors. It's very imperative that we also understand why the machine learning algorithm is doing something that it is doing. And there is like a lot of research, a lot of work that is being done in explainable AI, wherein they say that okay, what are the different features of, how do we say that the machine learning algorithm you have designed is fair, right? So it's not biased towards a gender, towards a race, and all those things. If somebody is going to apply for a loan, it's not biased on gender or the age of the person or the race of the person or the background of the person. He or she, if they fit um, the group, then they get the loan equally. Okay, so moving on. Yeah, so let's see, like, okay, so let's see like some of the things that we already interact a lot, like Facebook. We do a lot of, we spend a lot of time on this, and then we see that what are the different components that Facebook might be using, which we can say are like machine learning pieces. So they do a lot of textual analysis, whether it is messages, whether it is the data that they curate and show it to us. Then there is a facial recognition. Then they have advertising that they want to target different customers of based on like how you interact with different kind of information that they show. Then different kind of applications are also designed on top of whatever data they have. They have news feeds. Then they have different recommendations, what friends, who could be your friends or something like that. And then there is obviously like with all of these things, and there is a lot of data, then you also have to make sure that there is no spread of like false news or criminal activities or offensive video images, you try to, or fake news and something like that. Okay, and yeah, so moving on, for something like Google has a lot of tools, or a lot of yeah, so Google also has a lot of tools that we sort of like use on a daily basis, whether it is Gmail, whether it is YouTube, whether it is Google Drive, Google Docs, and all those things. So they also have like a lot of AI related activities that that uh, they sort of like work on. Like one is like how do you translate from the images. Today it's available on Google Translate. Then how do you do voice search? uh, how do you make sure that photos, you can apply filters, different kind of things you can do on top of like Google Photos. You have an option of doing a smart reply, wherein you get a message and the system itself says that okay, these are, what, like three different options you can respond to this email, and you can just select one, and then you can basically edit and send it. Then there is Google Maps, which is like another like it has like a lot of data about like how do you move from one location to another location, what is the best routing which is available based on the point A to point B that you want to go, based on traffic there could be, and all those kind of details. Okay, so this is yeah, so this is about OpenAI. I haven't mentioned it, but yeah, so OpenAI is one of the leading, I would say, AI research that's currently, and they are doing some of the like cutting edge technology work as well. So they have a very good funding as well from Microsoft. So they have recently signed a deal with Microsoft, wherein they are heavily funded by Microsoft. Obviously, it's like Elon Musk has the backing for this company as well. So they come up with very innovative and intuitive ways of like how do you solve different problems. So this is one of the problem wherein you would like to design or create images from the text data. So like for example, a baby daikon radish in a tutu walking a dog. And these are some of the images that you can see that, okay, these are all generated on the fly. So all these images are being generated on the fly. An armchair in the shape of an avocado, and you can see like this could be useful for furniture designing using 3D printing or something like that, right? Or something. So just creating images, so it's like a mapping of two different worlds. And OpenAI works a lot on, like from the side that we can see, they are trying to work a lot on AGI, which is artificial general intelligence. One of the cool things because about us is that we can link different fields intuitively. We can link that, okay, the images to sound to text, we can do this seamlessly. So this is a challenge as of now. Like it's not very straightforward in machine learning to do this kind of an activity wherein we can shift across different kind of fields and we can seamlessly work. So this is a very good or it's a very recent work as well. So yeah. Okay, and then language modeling, like language modeling, NLP, natural language processing. This is a field which has grown a lot, especially like with GPT-3 and all those very big models. Like these are huge models, which are like sort of like they have come using attention-based techniques, transformers, and all those things. So these models try to take a lot of information uh, and they do not need a label, so they do not take label. This is more of like unsupervised learning. So they would just take, for example, most of the networks or most of the NLP models that are being trained today is just that you feed a lot of text data to these models, and these models intuitively try to come up with a language model for English or for Hindi or for so many different languages. So you can just feed the one of the challenges with machine learning, especially in NLP, was that you always have to feed in like somebody has to go ahead and say that, okay, what is this? What does this mean about? Right? What does this mean? So there has to be had there had to be some kind of supervision provided to all these models, and that was very costly, and most and at times it was inaccurate as well. It leads to a lot of bias. Now today with all these models, you just feed in tons of Wikipedia data or a lot of books. For example, Google has a lot of data. They can feed in all their data, and they're doing that to create all these models, right? So they what they do is internally they will try to create some probabilistic model saying that given these words which have come, what should be the probability of the next word, right? And they have used like different other techniques like attention based models and all those things. So natural language processing is growing a lot. There is a lot of scope for work over there, especially in like coming years. It's not a fully solved problem. A lot of areas of research that's currently active in that field. So any one of you, like if you want to grow, like for now machine learning has become so huge that you have to pick your like different areas if you want to grow, and then later you can obviously you can come and become masters of like multiple fields. But to start with, you'll have to pick, like maybe I want to grow in natural language processing. I want to be an expert wherein I can build different models. I can solve whatever problems are there in natural language processing, which are available. And there's a lot of help. There's a lot of guidance available online for us to get started. Similarly, you can choose computer vision. Computer vision is another area which is growing a lot, and yeah, so you'll have to pick and decide that if you want to grow in machine learning, then you can have an overall idea about like what machine learning is, but I would suggest that you try to like isolate fields. Just don't try to like be good at like everything and then try to master or try to specially work on areas which are of interest to you and try to devote time on that. So yeah, okay. So this is yeah. So without any kind of explicit programming, we would like to create some kind of a decision-making system, right? Wherein we do not explicitly say that, you know what, like if this is the temperature, this is the humidity level, this is the wind speed, this is the season or the weather climate, or other details, should we go out, or should we have a match, right, a cricket match. So if those kind of predictions have to be made, they should be done like more in an automated way without us saying that okay, we create tens of rules and bring it on our own, right? Yeah, so I think yeah, so yeah, so they another thing is like these algorithms, once they get more data, they improve upon like whatever was their previous mapping. Because as of now, I'm trying to use the word mapping to keep it very simple, saying that this is the input word, this is the output class you want to identify, whether it's a email that you get and your email system, your mailing system, what it does is it marks it as junk email or spam email. How does it do that, right? So sometimes it happens that some of the important emails also go into the spam section, and then you go ahead and manually you say that okay, this, you know what, this is not a spam mail, and the system learns from it. And so yeah, so it can also learn with additional data that you provide. Okay, so let's see like some of the examples. Okay, so here what we want to do is like given heights in centimeter, we would like to tell what is the weight of the person, right? So this is the data we have, like the previous data, and we'd like to build a system which can predict that given any other arbitrary height, we can say with some confidence what should be the weight of the person, right? So from this data itself, we can see that there is some kind of correlation between height and weight, right? So we can see that people who are sort of like small in height, they tend to like weigh less, and people who are sort of like tall, they tend to weigh more. But yeah, I mean there are scenarios wherein the height versus weight is not directly correlated, but there is some kind of correlation. We can say that based on this data, and there are always exceptions. So one of the thing is like how much data is enough for us to start training the models, and this is a big problem because it's a big problem as in like creating a representative data for different scenarios is not an easy problem, or I don't think like as of now it's a solved problem as well. So generally what the companies do is they try to create or amass as much data as possible, and that is where you see that big companies have much more advantage than the smaller companies, right? Because they have tons of data that they can use, and obviously infrastructure to help to support that data, the size of the data. So yeah, so suppose we have some kind of a data wherein we say that we are not bothered a lot about how well representative this data is, but we are being asked that okay, you have been given this data, can you just come up with some kind of a model which can be useful and tell us that okay, tomorrow if I say that this is the height of the person, what should be the weight? So let's just see this. Like, okay, so there could be, we know that there is a correlation. So we can fit that correlation, and we know that it is like height and weight are positively correlated, right? So we see that when the height increases, the weight also increase. And we can fit a straight line. So straight line, something like this, and say that, okay, you know what, this straight line is sort of like representative of whatever this model we can create out of this data. So just see that we have not yeah, so let's go ahead. And how do you measure that how good this line is? Like this is where the optimization comes into picture. So by optimization, we want to measure that whatever solution we have provided for this model, like how good that solution is. So in a way, we try to understand that, okay, you know what, like I can see few of the data points which are lying on this line, which mean that for these points there is no error. So if this is my model, this line is my model, then I can say that for these points I am accurate, right? So if somebody says that this is the height, I can explicitly just using this line as my model say that, okay, this should be the weight. I can just draw a perpendicular on these two and then get the height and weight correlation. For some others, I see that there is some kind of an error. So the measurement of this error is like how different it is. So this is the for this particular height, this would be the weight that the model will predict, because our model is this line, right? So you can think about that this line, everything on the x-axis, if we just draw a perpendicular, and wherever it intersects with this line, that point itself is going to give us weight, right? So we can see that there could be errors, and these are the errors we try to minimize. So this is sort of like you change this problem to an optimization problem, wherein you try to calculate all these errors, sum up all these errors, and say that how do I minimize this error. And this goes to like calculus and all those things, right? So you try to minimize the error, and what is the way of minimizing the error is more about like you create the you differentiate it and try to find out that, okay, I want to keep it minimum. So all those kind of like there are different techniques of doing it. Optimization is like you can find a lot of work being done in solving all this kind of different kind of problems in optimization. Okay, so yeah, so this is what we would like to do. So we tweak the line, or we change this line slightly, or in a way, so that this overall error is minimized. So that is the overall thing that we try to do in most of the machine learning model, whether it's a deep neural nets model, we try to create errors about like what are the exact labels about different images or different text data, and what is the model predicting, and then we sort of like back propagate that error using some kind of a different of calculus techniques, right? We calculate basically gradients and see that how we can minimize the overall error. Okay, so what are different type of ML problems? Like there could be like this I've taken it from one of the slides. So most of it is like classification, regression, clustering, and all. So classification is more about like how do you pick one of the labels, whether it is a cat, dog, horse, whatever. How do you, for regression, it is like how do you go about, like for a stock market prediction, how do you say that what should be the value of the stock on one particular day or given past data. Clustering could be like grouping similar example. And there are a lot of problems, like ranking could be like how do you, like if you have so if we type in Google for any particular keyword, we get a rank list of results. So there, that is some sort of like ranking problem. Okay, so yeah, so machine learning, yeah, so we, yeah, this is another, like Peter Norvig is the Google research director, and so he says that yeah, so machine learning changes the way you think about a problem. It's not that you, it's earlier or naturally when we as a programmer we tend to start to think about a problem. We'll start with like logics and all those things. So it sort of like changes the way we like think about different problems. It could be like different, totally like, yeah. So the idea is more about like being data driven rather than intuition or logic driven to start with. Obviously, the logic is going to help us, but it's more about the signals we are getting. Like if we show somebody some movie, what is his reaction? Can we capture the reaction and then understand that, okay, if our model is doing good or bad? right? So those kind of like more focus on the data driven logics rather than coming up with our own logic and then trying to fit into the word. Okay, so Scikit-Learn is one of the framework for machine learning. Now I'll just talk about maybe, yeah. So, so this is a general ML framework, Scikit-Learn. There are a lot of different frameworks available. For deep learning, you might be aware about Keras is one, PyTorch, TensorFlow, and all those frameworks are available. Scikit-Learn is for more about like a holistic machine learning kind of a framework. It doesn't do a lot of deep neural nets. It's I think there is an ANN model, but yeah, that's it. So it has like different groups. Like one is for classification, what are the different methods, and these are all the different algorithms that you can use out of the box for different kind of problems. For clustering, what are different kind of clustering algorithms you can run. Similarly, for dimensionality reduction, so if we can think about it in a way that if we have huge amount of data, then our feature engineering, our post feature engineering, the features that we get would be huge. How do we reduce the number of features? How do we only identify important features? This is called like dimensionality reduction. You want to reduce the features to a much lower number. Like say I had like 10,000 features from a particular data, right? Or 1,000 features to start with. I would like to reduce the 1,000 features to say about 50 features, right? And these 50 features are going to with a very high probability represent the initial data that I had, right? So what are the different so one of the things that we can think um, when we try to understand the logic of why dimensionality reduction should be done is like most of the data points that we have about when we are creating these features, most of them or many of them will have some kind of correlation, right? So some kind of correlation as in like there could be some kind of dependency that if this feature goes up, feature X goes up, then feature Y also goes up, or feature Z goes up, then feature say about W goes down. So there is some kind of correlation. What we would like to identify those kind of features which do not have any kind of correlation, because all these features would be assigned weights when we create models. And if we have a lot of duplicate or features who have like high correlation between themselves, then it will sort of like add additional weights, or the model would be biased because you are sort of like increasing the weight for all those. So you try to come up with features which are sort of like independent. So that is what dimensionality reduction does. They have like you can use eigenvectors to make sure that you can use this particular technique basically to reduce the number of features that you have in your feature space. And there are like multiple algorithms to do that, like PCA is one of the most standard algorithms. Then there is LDA for text and all those kind of things. Regression is a similar problem to classification, but in classification we had sorry, so we had like different labels, right? So if we want to classify an image into 10 different buckets, that's our labels. But regression is like for continuous uh, range. So it could be like stock market prediction. What would be the price of the stocks, uh, say tomorrow or whatever, right? So this is more of like the output that we are going to get in regression is continuous value versus a set of like limited amount of value which we can see in classification. And clustering is more about like I do not have any kind of labels to start with. I do not have supervised data set to start with. Then how do we go about creating some kind of notion of similarity for all these groups? Okay, so this again is like we are talking more in a similar way that what classification is. So when we have categories, right, that's what we told that what is the output variable. If the output variable is a category, whether it is red, blue, or whatever, then we say that, okay, this problem is more about classification problem. Yeah, so I think we can proceed. So yeah, so spam versus not a spam is basically a classifier which would tell you that, okay, these are all the spam emails and you'd like to put them in the spam folder. These are versus like not spam emails, so they go to your inbox. Okay, so yeah, so in the linear regression, we saw that in the height versus weight example that it's more about uh, uh, trying to find this continuous variable which is as the output. So over here in linear regression and the logistic regression, what we are trying to say is like if we have only two classes, right? So y is equals to 0 and 1 are two classes. Then how do we do that? We can use some sort of like sigmoid function. So sigmoid function is like once you have some value which is close to 1, then it will set it as 1, and the values which are closer to 0, where it will set it at 0. So it will basically take the uh, the output probability, and then it will create classes out of it. So this linear regression kind of a problem wherein we have like continuous output predictions, we can sort of like pass it through the sigmoid function and we get like a couple of classes out of it. So that is what logistic regression does. Logistic regression, even though the name is like sort of like regression in it, but it's more of a classification. Yeah, yes. Okay. Okay, so this talks more about like what is classification versus regression problem. So it's more of, I think, yeah, so the it involves a prediction of discrete values in sense of like classification versus regression is more about the continuous values. There is no sense of order when we have like discrete values, whereas in the regression it's ordered. So it's like pretty straightforward that how do we differentiate a classification versus a regression problem? Like what is a regression problem versus what is a classification problem? Um, yeah, so I think like the overall idea is that we create in classification, we create some kind of a mapping function which is used to identify um, the predefined classes, versus in regression it's more about identifying some sort of like continuous output value. And different algorithms are there in different groups. Like for classification there could be like decision tree, logistic regression, etc, and here it's more about like linear regression, or even we can use random forest for that. And another thing is, yeah, so what is the method of calculation? How do we calculate that how good the model is doing? So we can measure like different, so these measures of saying like how good an algorithm is working is called metrics. So for classification, it could be accuracy, it could be F1 score, it could be precision, recall, versus regression could be a root mean square error, RMSE. Okay, so again, like we can see from this one, like what are the different examples which we can identify as like some of them are mostly a regression examples, like predicting age of a person. So wherever there is a continuous variable, or predicting house prices based on the area, predicting number of copies of music album will be sold. So these are all continuous, right? So this sort of say that okay, what could be the age of the person? It's not limited to say 5 different brackets or buckets or something like that. And then predicting nationality of the person, or whether the stock price of the company. So predicting the stock price of the company is more of a regression problem, but whether the stock price is going to increase or not, it's more about classification problem. Then what is the gender of the person from, like whatever information you have about that person. Or yeah, so it's more about like you have limited target groups or the output classes you want to identify. Yeah, and on the clustering pieces, you have all this, like we can take this example, which has different shapes and different colors. You'd like basically want to like post clustering, you'd like to group them together, right? So you do not have any kind of labels explicitly available to you that, okay, um, this is marked as like this should belong to this particular class, right? So if we say that A, B, C are three classes, then we do not have labels associated with all these objects. It's more about based on the shape of it or the features that we can extract. We try to identify similar objects together and group them together. So this is what the clustering algorithm does. Yeah, and these are like different examples in which clustering can be used. So okay, so how do we identify like what are the different customer segments? Or if we are given lot of different species of plants and animals, then how do we automatically try to group them together, right? And so on and so forth. I think we can move on. Now, dimensionality reduction, we talked about this in a bit. That okay, this is a problem wherein we would like to basically reduce the features that we have about any particular problem. We'd like to reduce it to a much lower number and still have enough information for us to help predict that what should be the class of it, right? So yeah, so in machine learning classification, there are often too many factors on the basis of which the final classification is done, and you would like to like basically reduce the number of features. And the overall idea is that you'd like to reduce the number of correlated features. Okay, so I can see that there is a question here. Okay, so electrical machines, can you explain AI application in controlling electrical machines? Okay, so I think like it's more about like a control system, and control system, especially in robotics. So, for example, yeah, so it's a huge field in which we'd like to understand the stability of the system. For example, take for example, we want to transfer or we want to design a system which can transfer huge weights, right? Or which can, if we are building heavy machineries and we want to make sure that this heavy machineries are being shifted from some other vehicle. It could be a ship. Like for example, ships are going to the port from which these heavy machines have to be lifted and put in somewhere where we can build the design. So one thing that's very important or that's very uh, vital is that the levers or the machines that you have, they should have stability, right? So stability as in like if you are picking something and you decide that what should be the torque or what kind of force you are going to apply, right? So you should be able to predict that the system doesn't take or lift the heavy machinery and put it in a way that you apply enough thrust on it so that it doesn't wobble. It just go, because if it starts wobbling, then then it will again result in some kind of like instability in the system, which could result to like a lot of problems. So there is like definitely there is a very big field called control system, which is in robotics, which deals specifically about this, that in machines, if you are doing this kind of, especially this kind of problems, there could be other problems like, for example, localization. right? So localization is another problem wherein you'd like to find that if you have a robot which is which is out there, you try to find out that okay, what is the uh, how should it navigate from point A to point B. So there are techniques in computer vision, especially in navigation and all those things, wherein you can identify that from point A to point B how the robot should go. And this could be based on like the GPS location. This could be based on like computer vision. It could identify that okay, what is the path it should take. So yeah, I mean, for all these machines, when we talk like this, I'm especially trying to target this robotics, wherein the robot can move from point A to point B, and what kind of different kind of problems that it can be associated with it, right? Or the heavy machinery side, wherein stability forms a lot of uh, a huge crucial role, wherein you have to identify like proper forces, and you have to also make sure that the systems remains in a state which doesn't break or and like there is a huge amount of like research as in to find the proper control system and all those things. So yeah, so I think I hope it answers the question. But yeah, there is like there are a lot of areas wherein uh, I haven't done a lot of work in electrical systems, but I know that in all these electrical systems, the feedback or the voltage and the power that you supply actually gets translated into some kind of force or the torque, which sort of like tends to move the machine or an arm or something that the machine does. And we can use some kind of prediction that okay, you know what, for example, for drones also, like how do you make sure that drones can lift an object of say whatever weight it could be, and can transfer from point A to point B. In between there could be trees, there could be like highway lines and all those things. So all this electrical system inside the drone, they sort of like identify that what should be the weight, what is the weight of the parcel that it is picking from point A, how much of an electrical current or thrust it should apply, what should be the force corresponding to it. So I think like in electrical system, especially drones and robotics and all those places, right? There is or heavy industries. There's a lot of places wherein we can identify. We basically have to identify that what should be the proper force and thrust and all those things. So that is where, especially for control or to identify that your system doesn't break in between if you're transferring something, whatsoever weight is there for that system, it should be able to identify that. So yeah, so I think that is one area that comes to my mind. But yeah, I haven't worked a lot on like electrical system. So yeah, these are like a couple of areas which directly come to my mind. So yeah, if you guys have any other question, then feel free to ask. If I know it, like yeah, so I can answer it. If not, then I'll let you guys know that okay, this is something I understand, and probably you can go and get or go search, and I can guide you into like areas where, according to me, which you should look at, and you'll get the answers. So yeah, so we can move on. Okay, so how does it work? At a very high level, these are like the steps that you do, that you try to pre-process your data, right? Pre-processing as in like you try to identify features for your data, and then based on the features, you construct your model based on like what is the target variable, that it could be a regression problem, a classification problem, or whatsoever like um, problem it is. Like you, based on your features, you try to create your model, and then you train the model on the data sets, and you do something called hyperparameter tuning, which tries to identify that what should be. So apart from the features, you also have some parameters which are model related, right? So you try to find the correct values for those parameters, and this is called hyperparameter tuning in terms of like machine learning. So when you are creating models, you try to split the data in a way that you can train it, and then you have sort of validation sets using which you tune it with one particular hyperparameters, or basically you can say that the models have knobs. So you can tweak the knobs of this model, and then you can calculate the metrics, whether it is precision, recall, with respect to like classification, or RMSE scores or R1 scores with respect to like regression problems. So you try to minimize this. So once you are done with like the training and the validation sets, you are in a position that you can say that, okay, this model performs best with this particular set of knobs, and this model I'm going to put in production. So there is a lot of work, like 2021 and also 2020, I think there would be a lot of work in ML ops. So ML ops does a lot of this kind of work wherein there would be auto ML coming into picture. Auto ML is like already we have the auto ML solutions from Amazon, like SageMaker is one, or there are different solutions which are like you just feed in the data, they will do all these activities that generally we have data scientists to do, and then they will tell you that, okay, what should be the output. So in machine learning, where the machine learning is trying to replace or augment the jobs in other fields, within machine learning itself there is a set of field which is like uh, which is sort of like it can be automated. So yeah, so this step is a like a standard step, and if there is not a lot of unknowns, or it's a standard problem, you have clean data set to start with, you can pretty much use an AutoML solution. And there are a lot of AutoML solution which does all this kind of things. Okay, so what are the steps? Yeah, so um, yeah, so what is the goal? Like this is one of the important things, that you identify what is the goal when you have been offered a problem to solve. Identify the goals, right? It could be like how heavy traffic would be on a given day. Then you come up with some kind of a hypothesis, right? So you would come out with like say about whether weather forecast could be an informative signal, and then you collect the data, like you come up with like what is the historical data on traffic, right, and weather each day, and then you try to test your, so you have a hypothesis that, okay, you know what, traffic is somewhat correlated with the weather. You may be right or wrong, but which you'll come to know once you test your hypothesis, but this is the hypothesis that you have to come up with, and then you collect relevant data which to back your hypothesis, right? And then you do the analysis of the results, whatever results you have got, and then you basically reach a conclusion. So yeah, so there could be like, once you have identified the goal, you would also know like what should be the appropriate metrics to use in this particular scenario, right? So whether it's a classification problem, whether it is a ranking problem, whether it's clustering, whether it is what kind of problem it is, right? So you also have some notion of like what should be the metrics associated with this particular problem. And yeah, so it's more about a repetitive step. Once you have done all the steps, you go back and see that, okay, you're not happy with the results, you need additional data set. Then what should be the additional data set, and again come back on your workbench. Okay, so what are some of the good problems we can say like for machine learning? So one of uh, uh, the benefits of machine learning solution is like non-trivial problems we can solve, right? So problems which we are not able to solve using traditional software engineering skills, wherein we write the programs for it, right? So what should be the response to an email, right? So that is a problem, that you can have enough data. If you are a system like Gmail, they'll have a lot of data wherein how people have responded to which particular email, they have this data to train their model on. But basically what you want to identify is your language model is able to understand. So there are a lot of nuances in this particular question itself, that how do I reply to an email. Replying to an email, if it's for a human, then the human should understand that what the mail you have got says about, right? So what is the context or summary of the mail? What is the additional information you need to know? And then how do you respond back to an email, right? So all it's like a non-trivial problem. And so you can identify problems which you cannot solve using, say, traditional software programming skills, which are more data oriented, is what I would say. That if you have enough data, and one of the critical challenges with machine learning, which we face even today, like we know, like there is a lot of public data set available. Like for example, take COVID, right? So COVID is we have a lot of research done on COVID, and what kind of data sets are needed to identify whether a person has COVID or not. So because of this current research that's being done, a lot of data set is being created as well, right? And if you are not doing, or if you are attacking a problem for which there's not much of a research that is done, then one of the key challenges you'll face is you'll not have a lot of data to start with. And that is like a key challenge until unless you are working in an industry which has its own data. So if you are working for an e-commerce industry, they already have a lot of data about like solving a problem of recommendation. So if you are working for, say, about Mintra, they will have a lot of data about like fashion recommendation, that what kind of clothes you can recommend to what people, right? But if you are not working for or suppose ads are like a very profitable business, right? So there's a lot of value in displaying the correct ad to a user, but you cannot find good data sets on ad anywhere. Like if you search Kaggle, if you search like a lot of openml.org, all these places, you try to find out that ad related data set. How do you do a personalized ad recommendation in different fields, whether it is like you're going to uh, um, sell a book like what Amazon does, or sell any appliances, sell anything. So for all those things, if you want to give personalized ads, getting good data, until unless you are from that industry which is doing that, and they have like, again, like navigation, right? So automated cars, if you want to solve a problem of automated cars, I mean, so we have some data sets, but will not have a lot of data set to start working on. So these are like, you have to understand that okay, some of the problems are there which are like which have non-trivial solution. They cannot be solved using like writing a program and you're done. And the second thing is more about like how easy it is for you to get data. If it's very difficult for you to get like correct data, then more often than not, then it's not a very good problem that you can solve from ML. You can solve from some other technique maybe, uh, but I don't think like machine learning would be a good fit for that problem. Okay, so yeah, so first of all, try to understand like these are like some of the steps that we already discussed, that try to understand what the problem you're trying to solve, right? So, and then you will come up with your heuristics or whatever yeah, hypothesis you have in your mind, right? So you'll say that okay, you know what, traffic is related with somewhat like weather. So if it is raining, then generally traffic gets to be clogged, the roads are blocked, so traffic won't be good. But that's not the only factor that is deciding it, right? So from point A to point B, if you want to go, you'll come up with some kind of hypothesis, but be prepared that your hypothesis might be challenged, right? Whatever assumptions you have made, they could be like completely wrong. And then yeah, so then collect data. Like basically, you should uh, you should work on a problem for which you have enough data, or you have a means of getting the data, right? So you should know that if you are working for a company, you should know that okay, what are the different systems which are there which can give you valuable data sets, right? So if you're trying to solve a HR problem, that you want to identify that which are the employees, if the company is facing a problem wherein a lot of employees are leaving, right? So if you are a data scientist, you join the company and they ask you that why don't you work on this problem, then you should know that where are all the systems from which I can get information. It could be like reviews, right? So review feedback data. It could be like yeah, so it could be like interaction with the colleagues. What is like day-to-day interaction? What kind of activities? More often than not, is the employee getting like proper challenging work for which his skill sets match with what the problem is. So it could be like if he is getting a problem which is beyond his skill set, or it could be another problem which is like it's too easy for him, right? So you have to find out all those like different signals have to be there. You have to make sure that you put a lot of effort if the systems are not there and somebody is asking you to build the problem and you say that okay, you can build it. So you should be aware that okay, what is the data that you need and how easy it is for you to get the data, right? So if it is very difficult for you to get the data, then more often than not you'll not be able to solve the problem. So or it might even result in like you have to you have to ask the management that you need this kind of data, and they will get the system in place, which very rarely happens. So this data collection part, though this is like very trivial, but this is the most important part. I would say like if you have the correct data to start with, then you can like validate your hypothesis, you can try out different hypotheses and all. And then like obviously like there is a lot of public data set, but most of the problem that you would be solving when you join companies as data scientists would not like very rarely you would be seeing that a problem wherein you can find public data sets. So apart from like few of the research papers which the academics publish, they also publish the data for that, so that you can very well use. But yeah, means if you are joining a firm, then there is a great chance that they might have their own in-house data. So critical advice or an advice would be that if you are joining a firm, especially in the data science role, you try to ask them that um, that what kind of problem they are solving. Do they have enough data? Like you'll get if you're joining Ola, you're joining an Uber, or you are joining something like a Swiggy. So you'll have a lot of data, and they'll be solving that problem itself. They'll not be solving problem in healthcare, right? So that way you'll be having a lot of data to work on. So yeah, um, yeah, and then basically like you should not try to like over engineer or do a lot of feature engineering on your end, because at times what would happen is you may not have enough domain or domain knowledge or expertise to come up with all the features or all the yeah, so all the features that would be needed. Well, you can always do, but try to use some automated way of discovering the hidden features, right? So whatever the latent features are, right? So in the image, it could be like whiskers of a cat or whatever, like which is explainable to us, but in the ML word, like it would be the filters that would be applied would basically identify all these things from the images. Yeah, and then basically see that as a data scientist, you would be more in like a decisive role. You would be making decisions, right? So you have to be very careful. Like uh, it's not like a toy problem that we are trying to solve. Your decisions will affect the company somewhere down the line. So it's like you have been given a role wherein you have the power to make decisions which can turn the revenues of the company. So yeah, so you have to have that kind of understanding as well, that okay, you are in the decision making zone and you'd like to uh, build solutions which are like sort of like responsible, and you have you can tell like what kind of explainable features are there. You can back whatever your hypothesis was, right? So at times it would be there that you create a solution but you cannot back your hypothesis, right? So you are getting some good results, all of a sudden we have seen that has happened with big firms like Amazon, wherein Amazon was guilty of their recruitment engine was biased against women, right? So they didn't know, and it happened only after a long time that okay, they found out that there is a glitch in the system. So they were not getting a lot of women candidates. So the system was biased. And similarly, sometimes we see that an African man is labeled by Google as chimpanzee or something like that. So there could be like a lot of hidden biases. You should be like designing your system. You should be able to like be in a position wherein you can explain that what your system is doing and not just create a black box model that and anyway, like if you are creating just a black box model that an AutoML system can do as well. So and there are a lot of tools, a lot of research is being done in explainable AI as well. Like you have papers written around how can you identify fairness in a model, how can you come up with explainable features and all those things, right? So if you are interested, then do read up about explainable AI, and there's tons of work that's being done, research work. Okay, so yeah, so means most of these problems they are not like 100% fit for a solution. So they are not that okay, there's only one way to solve a problem, right? So uh, I think like there is like a lot of problems which we start with very naive or basic approaches, and then later we try to find that okay, this approach doesn't work. For example, clustering, right? So you can or there was a problem about like I read up somewhere probably Geo was trying to solve a problem wherein they wanted to understand where they could put network towers, right? So that is a problem that how do you identify that you put a network tower in a location so that people can get signals, right? So that's a problem that they had, and I think that their team started with like thinking it as a clustering problem. So they tried to build the clustering solution and all those things, but at a later point they found that okay, it's not a clustering problem, it's like a topological space problem or something like that. So yeah, so at times it would be that we start with false notion, we might get good results in like the just to start with, but you have to do a lot of work around that to validate that whatever your hypothesis is stands correct and there is a scope of improvement, right? Okay, so yeah, so this is another thing is like anomaly detection. We see a lot like how do you identify anomalies um from the label data. So I think I will skip these parts. It's basically like yeah, so there are a lot of problems that there, these are not the only ones that's there. But yeah, I mean, seeing the time aspect of it, um, yeah, so I had few more slides about maybe the algorithms and all those things, that what kind of algorithms are there. Probably I can talk a bit on this. Dick, I see there's 15 minutes left. So should I just pause? Uh, like because I know like there is 15 minutes left on the clock.
Shanu, time is all up to yours, means you can extend also. It is means the session is going very wonderful, means we are enjoying it a lot. We are also learning a lot. So take your time, no issues. If you have time, no issues with the time.
Perfect, sir. Thank you so much. Yeah, so I would like to extend it a little bit more, like maybe by
Sure.
half an hour. Okay.
Yeah, please, please, please.
Okay. Okay, so let's go ahead then. Okay, so what are the types of machine learning algorithms? Right, so there could be supervised learning, unsupervised learning is what we have been talking about. And what are the different methods in this? Like, okay, so all of these methods, right? So if you see these methods, then we we have different ways of like tackling the same problem, right? So name bias is one of the approaches that is still used for spam filters, right? So identify whether an email is a spam or whether it's a appropriate email. So you can still use name bias. Naive Bayes is basically it uses prior probability and then tries to seeing the likelihood of an event occurring, tries to come up with a posterior, right? So which is based on the Bayes rule. The challenge with naive Bayes is like it assumes that all the features are independent, right? So all of these algorithms, whatever algorithms we tend to work with, they will have some sort of like assumptions in them. And one of the role of being a data scientist is like you just don't have to pick an algorithm from Scikit-Learn and apply it to a problem and then see it, like whether it works or not. You should also be in a position like you should be in a position to understand that okay, what are some of the assumptions in all these algorithms. So even if you are making a judgment call, like suppose for emails, somebody can question that why should I use name bias as a spam filter, right? So there is a relation between different words. If words are going to be my features, right? So words are going to be my features, then should I use name bias, right? So because it assumes that each of these words are independent of each other, right? So that is a very strong assumption, but name bias tends to work very well with spam filters. You could also use decision trees or rule-based systems, wherein you can say that okay, if you encounter these kind of words and then do this, so you have a chain of a rule, right? You can use something like that to identify. But yeah, means there are different approaches to solve the problem. The overall idea is that in a way you should be aware about like what are the pitfalls for the different models. Like some of the models, the pitfalls could be easily identified. For some of the models, it's not very easy or intuitive to identify the pitfalls. And sometimes what happens is like some of the models are more data hungry. So if you go for like deep neural nets and you do not have enough data to start with, and you build a system which is like 10 layers wide and all those things, then at times what would happen is that your model will start underperforming, or sometimes if you do not have the appropriate representation of the data, then also there could be problem that the model will overfit on one kind of a scenario, and more often than not that you will see that everything is being so generally we see like whenever we collect data, we see that the data is imbalanced, right? So we were working for, because most of the situations where machine learning especially is being used as of now is to find sort of like odd one outs, right? So most of the system is correct, and then all of a sudden you want to find out what is the faulty appliance that is being created, right? So most of the time the machine would create appliances which are right or which are correct, but sometimes some fault might occur, right? So you'd like to understand that that yeah, means you'd like to pick the odd one out, right? So this leads to, in your data collection itself you will have problems, as if like if you start collecting data, you will not have enough representative samples for the classes which are like misclassified or which are like faulty, right? For example, we were solving this problem for invoice exceptions. So you want to automate the payroll system in which there could be some invoices which are not which are not genuine, right? So people would try to raise false invoices, and you want to build a system which can identify like which invoices are for are are not correct, right? So we call it like an invoice exception problem. And if you see like most of the invoices generally would be good. So if you start collecting data, you'd get like out of maybe out of 100 only one invoice is such that it falls in
Shanu, your voice is not coming at the moment. Some connection issues there. Am I audible? Okay. Yeah. So we have received a message from Shanu's side. I thought we were having an internet issue, but it is over there. Not an issue. So let him rejoin. And I think those who are you are attending, you are enjoying it, and do convey your friends that what they have missed today. And it is one of the technology which is in high demand in the industry, as told by Mr. Shutang, Mr. Shanu Shutang also today in this session. So even if your friends can join now, do tell them that do join. We have still 30 more minutes to go. It has been said that we do not know down the line when all these learnings come, we get benefited. Sometimes we feel that this is the part which is not, this is the cup, this is not my cup of tea. But we do not know down the line that where we face an interview or where we meet a person and he is still, he talks about all these technologies. So even if you're from mechanical, from electrical, or any branch, these learnings are always important. So we send the mail to all the students, irrespective of the branch, to you. And I can see that many students from different branch were also there, though some of them have left now. So let's wait for him. Though a lot have been covered, but we wish that he joins soon, and we should have a our dean sir is also listening and attending the session. Let's talk to him.
तो म्यूट हो गया। Am I audible? Am I audible?
Sir.
Yes, sir.
Yes, you are audible, sir.
Dr. Mayank, are you there?
Yes, sir. Connected, sir. Connected, sir.
Okay. So I need to speak here now.
Sir, we are waiting for Shanu to rejoin.
Okay.
There is some network issue he's facing. Though he's saying that
Okay, let him complete his session,
Yes, sir.
and then I can speak few words on this.
Yes, sir. Yes, sir. Great, sir.
Okay, thank you.
Shanu. Okay. Means you are trying to enter by gkvv.webex or the client side. Okay. No, if the client is open, you can go through the client also. The meeting is there. Okay, so you are having that information in that link which we shared with you, or shall I give it to you? The meeting number is 176. All the participants, please wait. The speaker for the day is trying to join. So the speaker for the day, Mr. Shanu Shatang is back with us. So please, handing over, I'm giving you the rights, Shanu. You can take over and as per the talks with him, now he'll be concluding within next 5-10 minutes for the conclusion. And
Yes.
all the participants, they can kindly inform their friends that they can join back, those who have left. We are beginning with the session again. The session was not over. So handing over to Shan.
Yeah, thank you, sir. Yes. Okay, so can you see the screen?
Yeah, visible, perfectly visible.
Okay, sir. Good. Okay, I think we were here, right? Okay. Yeah, so this was the example. Sorry, guys, like I just got disconnected for some reason. I think internet may be the cause culprit over here. So, yeah, so for naive bias, I think, so let me go over it uh, quickly. So this is the probability associated with each of these words for this particular user. So this user, Alice, she generally tends to use great a lot. So that we can see in like the probability that is associated with it. And then for Bob, this is a different probability that is associated with each of these words. And once you have this kind of like prior, we say this is like a prior probabilities for both the users, then you can apply the naive Bayes rule, which is like a standard rule for using the likelihood. And so likelihood is basically how, so from the data you can get that if these are the words that's being used, then is the user Alice or Bob. So those kind of signals, once you get from the data and you have the prior probabilities available for both of these users against all these features, using this information, you can calculate the posterior, which is basically the model. So naive Bayes does that, and again, like the caveat with naive Bayes is it's basically it assumes that the features are independent. Okay, so yeah, so another algorithm is basically support vector machine. Um, what it tries to do is basically it tries to find some sort of a hyperplane which would divide different classes of data. So over here we can see that the green arrow could be one of the hyperplanes which divides this black uh, dots, which are sort of like one group of one class of objects versus the square blue square boxes, which are another class of objects. And the overall idea for support vector machine is how do you identify this particular hyperplane. And another scenario, it could be that what about the data which is not linearly separable, right? So there could be some kind of data which is there's no there's no hyperplane, a linear hyperplane which can cut the data and can create data sets of different classes, wherein we can say that okay, this belongs to class A versus class B. So in that case, you have some techniques in support vector machine which basically try to map it to a higher plane, right? So which maps to a higher plane in which this data will become linearly separable, right? And then when you transform it back, it's sort of like the hyperplane now is a circle, which in a higher hyperplane might be a plane or might be a linear, which can linearly cut the data, right? So yeah, so there are like different variants of support vector machines of how are you going to use across like different set of data. And a lot of research, a lot of work has gone into support vector machine. Like these were the main pillar, or these were the main algorithms that were used before the advent of deep neural nets. So people were doing a lot of support vector machines and identifying these hyperplanes, what should be like different data sets, how do you change the hyperplane, how do you change the order of like these variables, how do you map it. So those kind of work, there's a lot of research that was done mainly on support vector machines. Okay, and then there is decision trees, which are sort of like rule-based systems wherein you can identify that okay, if this is the data, then what class the user would belong to, right? So then there could be a base a rule-based system wherein you can say that if the age is less than this, then generally based on the data I can say that these people belong to high class or something like that. So identifying all these groups is what the decision tree does. Like there are mathematical assumptions or techniques which basically identify that what is the class on which you should split, right? So these are basically you are creating splits on different features, right? So these are different features. So for user one, the feature is like age is 23 and the car type is they have like a family car type, and then based on that you try to divide all these things. So you have to identify that initially what it does is like you have to come up with a strategy of what should be the first feature at which you would like to split the data, right? So this is what the decision tree does. Like it's not that difficult mathematically to understand that how they do it. Like it's basically identifying that okay, so this is the initial feature. If we split on this feature, then the system will come to a more stable state, right? So basically they calculate entropy and all to identify that before this split had happened, what is the entropy of the system versus, and then they use Gini index to identify that okay, what should be the splits. And yeah, so this is another way you can do it. And then k nearest neighbor, they do not, it doesn't create a model. So it creates given the data, what it does is it has a hypothesis saying that you are as good as, or the class that you represent belongs to the type of friends or the type of neighbors you have, right? So if you are you are with one class of people, then you tend to be your status, or like we are just giving an example from the last data, that what should be the class of a person, then we can say that okay, what are the neighbors this person has, or what are the friends this person has generally. So we can say that okay, similar people will have like similar classes and something like that. So it doesn't create a model. What it does is, like, whenever you give it a data, it tries to create all this similarity. Based on the similarity notion, it tries to identify which are the neighbors, and based on the majority of the neighbors, it would say that you belong to class A or class B or whatever, right? So the problem with k nearest neighbor is it's a very intuitive algorithm. That's a plus point, but the problem is, like, every time you have data, then it's like slow, right? So you have to load all the data and then you have to run through this algorithm. For rest of the algorithms like naive Bayes, it just has a rule, right? So once it knows that the proper weights and all those things, then it just applies it into a mathematical formulation and you get the output. So yeah, so how do you calculate k? You can use uh, different buckets of data, and then you can sort of like k could be a hyperparameter, and you try to identify that for what k this is, like, this fits best. Yeah, so this is what they are trying to do using a F1 score for different values of k. They see that okay, for this particular value of k, the highest F1 score is reached, and then you pick this particular k value, that is k is equals to 5, and put that in the KNN algorithm, and then for prediction for on the test cases, you just use k is equals to 5. Right, so this is how it works. I think we went into a very high level detail of like how do we do that, but basically it is like you're trying to find the distance between different points, and you have a notion of that similar points tends to be like very close to each other versus dissimilar points which are very far away. So yeah, so this is the notion that you can see that okay, all these are like it's an iterative algorithm. Something like what k means is also. So okay, so for deep learning, I think like I do not have a lot of material, but yeah, so it's basically it's inspired by the human brain, like how the neurons in the human brain interact, and yeah, so what you'd like to do using deep learning is just take this image of a car, whatever it is, and then you get the output. There is no step for feature engineering or feature extraction that we do in typical like SVM and decision tree and all those things. We do not do that. With deep learning, you don't tend to do that. You just have an image, you apply it, and then you're done. So yeah, so we have already, yeah. So yeah, I think we can stop here. I have few more slides, but yeah, I think we can stop here. Rest of the slides are more about that what are the different infrastructures. Some of the slides are about infrastructures and all that we have for machine learning. But yeah, so hopefully this session was useful to you all. I'll pause here and can take questions or
Thank you, Shwetank, Shanu. It was really a wonderful session and a great learning for all. The platform is open for the participants and your juniors to ask queries. They can unmute themselves or they can use the chat window also, because if you'll unmute, then it will become a quest. So it is better if you can write in the chat window. I can see one query from Amritanshu. So I'll read it. Is there any particular platform or platforms which will provide data science internship opportunity in summer 2021 for third year undergraduate students pursuing computer science and engineering? Currently, I know only one platform, bitgrit.net. Sir, if you share the name of other platforms, it will be more helpful for us. he wished to ask about any internship platforms in the field of data science.
So yeah, so I'm also not very aware of like any particular, but yeah, I can search from my colleagues or in my network. I can definitely search if there is any platform which is suitable. I think this is a good, yeah. So internship is very important. Like, yeah. So definitely I'll search. I do not have any answers for it as of now, Amritanshu.
Okay. Any other queries? Any technical query which is anyone face means?
So there is one question, sir, that I've got. I have studied ML from Coursera. I also understand the topics covered there, most of the
Okay.
topics, but sometimes I find it difficult in understanding the topics and while working on assignments. Yeah, so yeah, this is a general problem like you will face in data science. One of the reasons that we face this problem is like this is an evolving field. This is not a very stable field like say a databases, right? So databases or say programming languages, so it's more stable field. But when it comes to data science, whatever we have covered today, like you are like expected to uh, sort of like there is a lot of help available. Especially you should be able to you should follow for example, if you are trying to solve a recommendation problem, right? So try to see, like you'll get a lot of videos on recommendation, like different techniques on YouTube, like that should be very helpful. Other things are like, yeah, going through books can be very daunting at times because of several reasons, because sometimes the books are written by professors who are who are teaching this field for more than 20 years or so, right? So they will write for, maybe it's not a fit for us as well. They would write for PhD students or something like that. So yeah, so the problem is like this field has a lot of, like a huge, uh, we can say that there is a very big learning curve associated when it comes to like different roles and different people who are doing like research, heavy research, especially with Google and Facebook and all these companies. They will tend to have mastered one particular field and they'll have a lot of information in that field. So if they write, and there is also a notion that these days publishing papers, people who publish papers generally tend to write lot of heavy mathematics in the paper so that their work gets published. So yeah, so that is the challenge. But what I would say is like you can always read blogs, like they are very useful blogs. Then you can try out few examples. There are help, I mean, you can get a lot of help from online community for sure. You can follow open source projects like on GitHub. If you guys are following, like try to follow few people who are doing cutting edge work in, and in ML, like you'll find a lot of Git repositories. So you can try to check the Git repositories which have more contributions, which have more people, or which is more active. Yeah, I think like, yeah, but yeah, this is a problem we'll face because the learning curve at times for problems that we get, we may not have the desired, mathematical backgrounds. Then we have to go back and try to learn some of the mathematics and then come back to solve the problem. So this we all face, and it gets like a bit easier once you are like doing this for some time. So yeah. So with
सर
Saket,
मशीन लर्निंग और क्या कहते हैं एआई में क्या अंतर है?
so machine learning is like a, you can say a subset of AI. So AI could be like deep learning as well, right? So in machine learning, we are saying like machine learning could be more about the classical machine learning. I don't think like you should be बहुत ज़्यादा bother नहीं होना है कि यार AI क्या है, data science क्या है. You should have a notion कि यार data science is like, okay, it also includes maybe mathematics and all those things. AI, I can say that it includes like traditional classical machine learning algorithms as well as like deep learning algorithms and all. That's what.
Thank you,
So
Shan. Our Dean, Professor Madan, is also there with us, and he has attended the complete session of yours, and the session was really very well explained. So, handing over to Professor Madan for his blessing words.
Sure, sir.
Madan, sir.
Yeah. Thank you, Dr. Meng, for inviting me in such a wonderful lecture by Shanu Shweta. I think he is really a scholar, and we are proud to have him in this group and as a mentor for the new initiative by Government of India and AICTE, in which they are focusing on innovation activity, internship activity, ICR activity, and startup activity. So I know that the computer science and engineering, this department is very, very innovative and has always been taking a lot of initiatives in inviting our honorable alumni to address to their juniors. And this machine learning lecture was really wonderful because I also learned so many interesting things and a few things which we have been doing through Amos and SPSS software in like clustering and all that. So I really enjoyed the examples given by Shanu on from industry on various industry. Like he gave example of geo towers and installation, and he discussed about how they thought that it was a clustering problem. So we have been doing clustering analysis with the help of software, but definitely when where the human mind it ends, I think the machine learning starts, and definitely the fatigue part of human learning is always there, where human brain starts it stops working due to fatigue. And also the example of mantra in which on a website automatically the machine is actually suggesting based on the requirement of the customer. You get some feedback from the customer, their requirements, and then you suggest few uniforms, dresses, and apparels to them. That was a wonderful example. He also discussed about the pollution and traffic issue and how machine learning can help in solving these issues. And then the name bias or the spam filters, that was again a wonderful example. And lastly, the machine learning and deep learning, the difference between the two. So I wish that most of the participants here, the students and the other teachers and others scholars who are here in this program, they must have learned a lot. And Dr. Mank, I wish good wish for this computer science department. I convey my wishes that in future also you will be inviting such scholars, such your intelligent alumni to conduct such kinds of programs, and we can send their report to the AICT and Government of India also, that means the peer-to-peer learning or senior to junior learning, or the water flow, or this waterfall of flow of knowledge from the scholar like Shanu Shiltang, the entrepreneur Shanu Shiltang, to the other, his juniors, is continuing in FET. So I wish a lot and a great success to all of you. Thank you.
Thank you, sir. Thank you for your motivational words. Uh, so now, may I request, if possible, by you all, those who are attending, can open their camera and we can have a group photograph. And Shanu would also love to see his juniors also.
I have a question.
Yeah, definitely. Thank you, Pankaj sir. It was great.
If more of you can open your cameras, some of the juniors. So let's wait. Most of you are connected from the mobile phone. In the mobile phone also, there is an option you can open up with your camera also. Due to this webinar, we are also able to see Shanu, means our current students also, because of COVID, online classes are going on. And in classes, most of the time, the camera is off. So through these webinars, only we interact and we feel good to see you also after a lot. So let me.
Same here, sir. Same here. Seeing everyone after such a long time, it's like really good. And best wishes to all the juniors from my end.
Thank you. Thank you. We'll be connected. And with these words, we uh, end this session. Thank you all for joining. And it was really a lovely interaction and a learning experience for me too. Thank you.
Thank you, sir. Thank you
Thanks.
for inviting me to this session. Really useful for me as well to understand how
Thank
it
you.
worked.
Thank you for joining.
Bye.